We will be talking about classes and objects in this video. We'll start with an introduction to classes and objects, then we'll understand what a class is, then we'll be creating our own classes and we'll be making our own objects, then we'll have a look at the new and the dot operator, and in the end we'll see how we have methods in a class and how they define the behavior of a class. So let us begin. There are three things in front of you. There are three objects. What is one thing common between all of them? There are a lot of things common between all of them, but how will you classify them? So you can term them as smartphones. So in the real world, what happens is there are various objects of the same kind. Now, an iPhone is a smartphone, a Nokia Lumia which runs the Windows OS is a smartphone, the Samsung S3 which runs the Android OS is a smartphone. So there are various objects. So you can call these as objects of smartphone. So there are various objects of the similar kind. So these three can be termed as a smartphone. Now we can say that there is a class smartphone and these phones are instances of that class. Now class here kind of stands for a blueprint from which the individual objects are created. So you can say that there is a smartphone class and it can have various kinds of smartphone, thousands of smartphones. It can have an iPhone, it can have a BlackBerry or anything else. So there is a basic blueprint and from this individual objects are created. Just understand the concept that in the real world there are various objects of similar kind. Now each phone has some components which categorizes it into a smartphone. Let us now write the code for the same as in how it will look in Java. So we use the class keyword and we define the name of the class smartphone. Now what you are looking at are fields. And these fields define the state of the object. So I have just taken 4 fields here, but there can be many, and for a class like smartphone there are many fields. So there is a string manufacturer, there is a string model, there is a double storage which tells the storage a smartphone has, and say a screen size. Now the objects of the smartphone will be defining their own values of these fields. For example, an iPhone might have 8 GB of storage, let us say, which is somewhere around 8000 MB. Now on the other hand, a BlackBerry might just have 2 GB of storage. So for an object BlackBerry of the smartphone, the storage might be just 2 GB, and for an object iPhone of the smartphone, the storage might be 8 GB. So, and for our example which we'll be taking, let us assume that we'll be assuming storage in MBs. So these are basically the fields and these define the state of the object, and they will be different for each object and they will actually define what an object is. So let us now define a class. So what a class does is it defines a new data type. As we had seen, integers, double, etc. These are data types, but as we know, when we model the real world example into a program, these are not enough. We need to basically create our own data types depending on the categories. There may be different kind of bicycles, there may be different kind of phones, there may be, for example, we took the example of a smartphone. So class creates a new data type, and this new data type can be used to create objects. So for example, if we have a class car, so we can have a Ford Mustang as an object, or we can have any other car as an object, and these are basically the objects of that type. So a class is basically a template of an object, and these objects are instance of the class. Let us now create another class. Let's call this class as box. Now there can be different objects of the kind box. There can be a magic box, there can be a soap box, etc. So, and we'll be defining three fields. One is length, breadth and height. And a magic box can have large amounts of, can be very large. The length, breadth and height fields can have very high values, whereas small box, soap box can be small. So these are the objects, and each object will have its own set of fields. So magic box will kind of have its set of length, breadth and height, and soap box will have its set of length, breadth and height. So this is basically, these are basically the objects of the class box. But remember, when we write this part of the code, class box, we have created the only template. Now when we create an object, we can have thousands of different boxes or objects, but this part has only created the template as of now. But what do we do to create an object? So for that we write this code, this whole code. So understand here that when I write box soap box, what this part is doing, this is creating a reference variable. And when I write new box, this is basically the class name and the open close parenthesis and a semicolon. This whole statement is creating an object with its set of fields or instance variables, and the reference variable soap box is referring to this object. So each object will have its own set of instance variables. So now soap box has its own height, length and breadth. So this is how we create the object using the new operator. Now what the new operator is doing, it's basically creating a new object, and we know that object is an instance of the class. So, but remember, class is just the logical framework. Object is the actual physical reality. And this is the syntax of creating a new object. We use the new keyword, and we basically write the variable name and we write the class name here. So we have the class name, variable name, new keyword, and again the class name using open close parenthesis. So, and this will basically create the object. Now we want to access the object variables and methods. Suppose we have a soap box and we need to specify the height of it. So we do that using the dot operator. So when we are doing soapbox dot height is equals to 22, the instance variables which soapbox had, say this was height, it will get the value 22. So that is done using the dot operator, and this is how we access the variables. Let's have a quick look at an example where we find the volume of the box. So this is where we created an object and soapbox is referring to that object. Now we basically specify the height, width and length of the soapbox. And once we define the height, width and length, we are basically multiplying those three and we are finding out the volume. And just remember that each instance variable is accessed using the dot operator. Now the important thing to note is that classes need to have both data and behavior. So these are the instance variables and that's the data. But the objects of classes also perform behavior, they interact with the outside world. So for the same we have methods, and methods represent the behavior of a class. So, but also remember the fact that a method is always invoked relative to an object, except when it is defined as static, which we'll see later. But let us see through an example how methods in a class work, and the idea will be more clearer. Now we take the same smartphone example which we took earlier. Consider other fields come here and we have storage, and storage is in MBs. So consider a method which we have called click picture. So click picture is actually a behavior or an interaction that the object of smartphone will be doing. Now when a picture is clicked, the storage is decreasing by 2 MB. So when an object will call this method, its storage will decrease by 2 MB. So this is basically a function in a class, and this defines behavior and interaction of the object. For example, when you have the dog class, now a dog barks, or when you have any other class, it basically performs a behavior and an interaction. So for example, when smartphone clicked the picture, its storage reduced by 2. And methods basically define behavior and interaction, whereas fields are basically for the state of the object. Now let us take our example of the class box and add a method to it. Remember that this time earlier we found out the volume in the main class, in the main method, but this time we'll be calculating the volume in the class itself, and it will become a method. So each object, say magic box or soapbox, can basically directly access this method, and when magicbox.volume will be called, the method of this particular object associated to that object volume will be called, and height, length, breadth of the magic box will be taken, and it will return basically a double value. So when we say double v is equals to magicbox.volume, it will basically return me the volume of the magic box when height, length and breadth of the magic box are specified. So this is something which is behavior or interaction of the class, and this is a method, and these are basically the states. Now notice that a method does not need a dot operator to access the fields of a class, because this is within the class. And what is happening on the main part is that we create basically the object pencil box, or you can call it a soap box, or you can call it a magic box. Now this is basically creating a new object of the class box. You are setting the height, length and breadth of the same using the dot operator, and when you print the box.volume, then it is basically calling the method of that class, calculating the volume and returning that. So from our earlier example in which we were calculating the volume here, now the volume is basically a method of the class itself. Let us now summarize what we have learned so far. Class is basically a blueprint from which individual objects are created. But classes are just logical frameworks. The physical reality are objects, and these are created using the new operator. And classes have data and methods both. Data or the fields represent the states, and methods represent the behavior.